Thank you, Dr. Cheyan, Dr. Kamal Shikli, and Dr. Pragati for the platforms. I think without wasting much of time, I'll go get into my presentations where I'll also speak in terms of the various aspects of the functioning of the editorial board, as well as in terms of the internal issues that many of us are unaware of it, or which is present within the editorial board. To start with, I have a disclaimer. This presentation is purely in terms of sharing the information and knowledges, and I don't have any commercial gains. I acknowledge all the images or informations used in this information. So first and foremost, I wanted people to know what is this editorial platform is. It was started 3-4 years back to promote the vision of the journal. Because the present situation is totally different from the earlier situations where we have to popularize the journals. We have to sensitize the members in terms of the various activities of our journal so that everyone can get collectively involved in terms of the betterment of the journal. So that was the reason why we started 4 years back in terms of a lecture slot in conventional conferences. So vision is known to people. Obviously, it's been an established journal for the last 50 years, almost close to 50 years. And everyone had an idea of making this journal the top. And we are slowly in the process of achieving it. Popularizing the journal among members, we had some limitations. Of course, everyone was keen in getting the hard copies, but not people were keen in terms of reading and promoting the journals. In the promoting journals, we talk in terms of by word of mouth. We want the members to popularize a journal. One second thing is in terms of by scientifically, we want members to cite our journals. Last few years, we have been doing that, but we want more members to actively participate in terms of, we have been very keen in terms of promoting this aspect of the journal. And the third is going to be a lecture to educate on the needs and the future of the journal. Basic research methodology workshops and basic reviewing workshops has been conducted across by the society as well as from the other organizations. But still, we found that when it comes to journal point of view, we found certain things are lacking behind. So we want our members to know in which perception we want to look into the articles, and where we look into it, and what aspect we are more concerned about. So our education series is going to be in terms of various aspects of the basic sciences or the basic aspects of your research methodology, and in terms of your journal writing is being discussed in this editorial board platform. In this regard, I thank the head office as well as the vital space that is quite significant, because it's not easy to push a lecture slot among the other lectures that is of paramount importance, because this deals with the basic lectures and basic education, which may or may not be liked by many people, but this is an important aspect of the journal in which I want to sensitize all the members. Many of our senior members and of my generations know about who have been handling the journal at front, but this is the information for the new members and a lot of student members who may not be aware of who are the people who have been handling these activities for a long. We started in 1972-73, and we did have a standardized publications in the 70s, but as an establishment, as an editor, it started in the 80s. We had Dr. Bhargava, Dr. Inyabar, Dr. Ajay Lal, Dr. Subbarao, Dr. Nadigar, Dr. Khakni, who have been the editors from of those 2 decades, that is 80s and 90s. Later, it was taken over by Dr. Swasni Nagda, who was more instrumental in pushing our journal to the next level. We call her era is supposed to be called as the modern generation of for the Journal of Indian Prosthodontic Society, because modern generation is not in terms of aging, it is in terms of the thought process which we have to push in lines with the international community. So we started in NER period in terms of documenting in the more advanced levels, and we happened to shift to the digital platforms. It started in early or late 90s. That is the first movement, first significant activity which we happened to push out. Next, we have the editors, Dr. Ravindra Savdi, who was instrumental in getting our journal indexed in PubMed Central. That was a phase which is very critical because the regulatory bodies like Dental Council were insisting on terms of publications make people happy in terms of getting the journals articles publication. It was enormous task to handle 300 plus colleges, and everyone was keen in getting published. And he happened to push in terms of the best of publications and getting it recognized in PubMed Central. And Dr. Shilpa Shetty, who has been the most dynamic and contemporary editor, who was my earlier past editor, after which I took over. She was instrumental in getting the basics right in terms of the international needs, because what I claim to say is things have been rapidly changing in terms of the requirements of the journal. So at the present situations, whatever we have is totally different from what we have been practicing 10 years back in terms of the journal front. So to instrument that, she started with a lot of the initiatives in terms of getting the basics right, especially in terms of scripting the editorial board, in terms of varied divisions and disciplines, the content of the articles, and structuring in terms of the various aspects of the journal has been taken over by her. Fortunately, I took over from 2015, and I was working with all the three editors, so it's easy for me to take over and do whatever the best I can. The most significant part, which I want all the members to know about, is we have been tied up with UNESCO Chair of Bioethics and National Dental Bioethics. This is a voluntary initiative done by our society. The head office has taken the initiative to see that our things are being registered at the best of platforms and get the best of recognitions. So we have a lot of initiatives being made by this National Dental Bioethics and UNESCO Chair of Bioethics, which is necessary in terms of our society as well as in terms of journal front. This is sensitize our members that we are in association with the best of organizations in terms of ethics. So we greatly bind with all the ethical principles in terms of our editorial board activities or in terms of the society activities. We were the first organization to initiate the competitions, which is known to members, like systematic review competitions. And present we have, which is they are randomized clinical trial competitions, which ended up yesterday. So these are some significant activities done by the editorial board. They are overworking to a great extent to get in lines with the international norms. And fortunately, with all this hard work, we are able to get the improved metrics and indexes. Jan 2021, we happened to get recognized by the Medline, which was a dream for the last 20 years. We started with Dr. Suhasini Nagda. She was initiating things. That's the reason why I was talking about changing in trends and policies. We wanted the journal to get indexed in Medline. It's a long process. Fortunately, we happened to get it in my phase, that is this year. And we are indexed with almost all standard agencies like PubMed Central, and in the process of getting into the Web of Science and Scopus. And there are a lot of metrics data. We have improved site score to 1.8 from 1.5. Of course, we moved down into the quarantile. That is, we moved to Q3. We were in Q2 last year. We improved in terms of the H index from 10 to 20 this year. And among general dental category journals, in terms of the Scimago rating, we are the 64th journal among 111 journals. So this is the one which I was very particular about in terms of the members to know about it. From the editorial board, we are there to scrutinize in terms of the quality publications. But if at all we want to improve in terms of this metrics data, it's up to our members. We want our members to cite our journals in terms of in their publications, especially, not necessarily whenever they write it to the Journal of Indian Prosthodontics Society. We want all the members to cite our articles in their publications. Approximately, we have 300 colleges in terms of the academic front, and there's going to be around 5 to 6 faculties in each college, whether it's going to be a postgraduate or undergraduate institute, and we have a lot of interns doing publications now. We have postgraduates, by default, they're doing publications. So if you cite 3 to 5 articles in your publications, shall have a improved metrics. Our journal is available freely now. It was available freely in the Indian servers earlier. Last month, I happened to open it even for the international servers. So it's in the free to download in all the platforms. You can download it from our journal website, or it can be done from the PubMed, or it can be done from the IPS website. For the IPS website, you have to log in into the membership category column, then you can download any articles from our IPS online website. The IPS online website also has the archives, which cannot be seen in few other websites. So we have the archives, whatever we happen to collect from 2000s, we happen to upload in the IPS website. So we have volume of literatures, volume of data that is available. Almost every aspect of the disciplines of the prosthodontics is covered. So I request all the members to cite articles so that we can improve in terms of our metrics, which is more significant in terms of the present situations. Coming to today's lecture, that is pro statistics, which is something significant for the present needs. I think major complaints that happens in terms of editorial board is in terms of the desk rejection of the article, which is very significant in terms of the statistics. That's the reason which I want people to be aware the aspects of statistics in which, at least the basics in which the editorial board looks at. This is a more dry topic, I do understand, but it's very significant in terms of your publications as well as in terms of the clinical situations. With the present situations where we think in terms of a lot of evidence-based dentistry, without statistics, understanding in applications, we cannot practice evidence-based dentistries or write a systematic review or even a primary research article. As such, I requested many people to speak on this, but looking at the domain of the topic, people are not really keen. So I happen to take over and start redoing the presentations or represent it again here. Of course, people know what is statistics. The science is vast. My talk is going to be in terms of the basics. Many of you might be aware, but I can give you a little bit of inputs that can help in terms of your publications, especially which the editorial board looks in, as well as in terms of the other international boards, editorial board looks in. There's some basic blunders we make it, which has to be corrected so that it can help us in terms of improving our publications impact as well as in terms of the acceptance rate. So statistics has its applications. Basically, it was thought in terms of economics. Later, it got viewed in terms of the politics where predictions of winning and losing has been discussed. Now it's greatly done in sports. You can see every ball in cricket has some statistics data that has been analyzed and people can predict the win or lose results of the match much early. Biology, we have been doing it, but not much emphasis has been given. We actually were deviating away from taking the numbers. We thought it's mathematical. When we don't want to get into the biological aspects of statistics, we deputed the statistician and we were totally out of that seats. Biostatistics is connecting to living organisms or any research that has been associated with the living organisms or biological tissues. It was an essential component. In the last decade was greatly being dealt with in terms of epidemiology or community health medicines or dentistries. But nowadays it has got its greater applications where we have to understand the applications in terms of the prosthodontics and in terms of the dentistry. Health research, where you happen to make a lot of inferences and interpretations in terms of the data that is available to us. So if at all you want to make a policy decisions or predictions or projections and preparations and treatments, we have to understand the statistics. And the important practical example is the COVID, what we happen to see in the present situations where people predict, anticipate the second wave, third wave, and all this has been done with the help of the statistics. So if at all you have an understanding, it is a valuable tool for us in terms of the research designs as well as in terms of the inferences that we make. Mostly it is misunderstood. It is essential that we understand the parameters of the statistics greatly and interpret it properly. It's not no more a discipline where you just give it, hand it over to the statistician and you keep away. Once you get the graphs or charts and the p-values, we just fill it up. People have been interpreting and simplify the data and make effective inferences to solve the problems that has been created. The various steps in the biostatistics is involves in terms of the hypothesis, collection of data, applications of analysis, and the data extraction, the way it has been distributed, analyze, and make conclusions. So earlier, we were just thinking it's a component of your dissertations where the result section has been given to the statistician, we get the analysis, but now it's different. You start from your research designing or in terms of the hypothesis framing. So unless you have an understanding of the basic statistics, it's difficult for any one of us to go on with terms of designing the studies. Basically, it is two types, descriptive and inferential. Descriptive is going to help in terms of giving you the information about the population in terms of age, gender, and what are the common characteristics. It's broadly, again, divided into terms of estimates of central tendency and the measures of variability. Mean, mode, and median is known to people in terms of central tendencies, and standard deviation and other correlation coefficients are known in terms of people in terms of the variability. Inferential statistics, the one which majority of our concern is because we get the p-value. We talk in terms of significance values, significance of the studies, but the interpretation or framing of the hypothesis then goes to the testing and discussion of the results. So basically, we think in terms of two aspects in terms of inferential statistics. One is in terms of the standard error of mean or deviations and confidence intervals. Before going in detail, I want to emphasize why it is going to be significant for prosthodontics, because majority of us think it is not applicable to prosthodontics. It's going to the basic science, which is going to be part of your part one MDS post-graduation examination or in terms of the public health dentistry examinations. Almost everyone speaks on research now. It's essential that you have and assess the research, what has been done, as well as in terms of what we are going to do. It's not just blindly taking up the data of what people have been doing it. We should also be in a position to interpret the data. So extensive research has been done across the country as well as in the various parts of the world. So we have too many data that is invalid statistics. Next is in terms of meaningful information from the raw data. We have some true data. We have some raw data information that is available, which has to be interpreted in the best of needs for the present situations or having a better clinical application. So you need an understanding there. And having a knowledge on statistics will help us in terms of obtaining the best of decisions in terms of the results. And we have too many variables, especially in the prosthodontics. We don't have a definitive relationships or understandings in terms of the variables. Say for simple things in terms of the impression. Each school of thought talks about different impression materials and different impression techniques. The reason is we have not generated evidences because of poor understanding in terms of this statistical data, so that it can help us in terms of improving our research designs and standardizing so generate evidences that can be useful for our clinical situations. The establishing of effectiveness of your data and the materials and procedures is paramount importance to generate the evidences. So this is important for most of our researchers as well as the clinicians, because without this understanding, we cannot generate evidences. It also helps in terms of the manufacturers who can claim the superiority of the materials once your study designs are going to be unique, distinct, and it's going to be standards with the data. The manufacturer can claim the superiority as in terms of the quality of the materials and persuade the clinicians to buy. And the most important, with the understanding, the clinicians can modify the way of practices, can move towards more in terms of evidence-based practices. Additionally, as Indian Prosthodontic Society or in terms of the Dental Council of India or any other regulatory bodies, they can structure guidelines on the basis of the evidences obtained, the statistical data that is available with us. The studies might become more simpler when we understand things, and enables the researchers to get into more depth in terms of the understanding of your statistical information as well as the study that has been done by us. So stages of statistical analysis doesn't mean it starts with the results. It starts with the research questions. You have to identify the research problem. Of course, this is a part of your research methodology, but still this understanding of the statistics helps in terms of framing your research problems. Going to be in terms of the prevalence rate or incident rate of some disease or some problem or disorder, which helps us to help in terms of, unless you have these data, we cannot construct a hypothesis. Defining the populations so that in terms of the grouping also you can decide accordingly in terms of the statistical information you have. Planning the data collections, whether you want to simplify data or you want to integrate data which has to be collected. Analysis of the data, compiling, then you go for a descriptive or inferential studies and obtain conclusions from this. So these are the stages of the various statistical information we have when we have to go in terms of the analysis. The type of data we collect is going to be basically in terms of two, the primary or secondary data. The primary data are obtained in terms of your any research. It can be in terms of observation studies or surveys or experimental or interventional studies. It can be in the form or in forms of electronic. The secondary data are more used in terms of generating evidences like systematic reviews and meta-analysis. Primary data is in terms of more in terms of our research, primary research which we do. Coming to the basics, which is known to people, but still I want just to have some continuity in terms of my presentations. I'm describing a part of the basics here. Data can be divided into numerical and categorical. Obviously, it is known what is categorical and numerical. Numerical is a quantitative value which can be measured. Categorical is qualitative value which cannot be measured. It can be of two types, nominal and ordinal. Nominal is going to be more of a dichotomous, like just two options, male or female, yes or no, in terms of nominal data. Ordinal is in terms of the satisfaction positions. I'll be discussing. So nominal data is used for more of labeling variables. It doesn't have any quantitative value, no numerical values or significance. As said earlier, it is dichotomous, only in terms of two options. Either it's two options that is available, you have to differentiate among that. Ordinal scales are again a non-numeric concept, but it has got a scale of measurement, like patient satisfaction ranges from 1 to 5. We use a lot of visual analog scales or OHIP questionnaires, where it has some variations like 1 to 5 or 1 to 3, you have different variations. So those are called as ordinal scales or ordinal data. Intervals, you have a definitive values. Exact differences are known, like temperatures. It's where we have each and every value is same, but you have a different numerical data which can differentiate it. Ratio is as equal as similar as that of interval scale, but you have a definitive 0, and it's going to be in terms of the ranges. But you don't have ranges that's extra varies in terms of numbers, say 1 to 5, 4 to 8. So whenever you have in terms of ratio scales, we have ranges, it comes into the ratio scales. Next terminologies, which I expect people to understand, is the descriptive statistics. It describes the data and do not make any inferences. It helps in terms of summarizing and organizing the information that has been obtained from the study, say in terms of the age, the gender, the population characteristics, history of ventures, all that comes in terms of descriptive statistics. Though we go in terms of a detailed statistical data, we just collect basic informations like how many people are redentulous, how many people are dentulous, or how many people have some diseases. All that comes in terms of descriptive statistics. We don't give any numerical justification to say that this is better than that. That is going to be descriptive statistics. It's more done in terms of explained in terms of measures of central tendency and measures of deviations. The mean, median, and mode is known to people. I don't know average value. Median is going to be the center value, and mode is going to be a more repetitive value. The measures of spread is going to be in terms of standard deviations or mean deviations or range or quartiles. Standard deviation is a deviation from the mean. So you have 100 patients which you have evaluated, you found a mean. So all the 100 patients are not going to be same in terms of the mean. So you have a deviation from the mean. So that is going to be the standard deviation that you're going to evaluate. What is the significance of this standard deviations? If it's low, we say that the population characteristics are more or less closer. If it's high, we say that it's going to be higher in terms of values. Yes, remember something, SD is never negative and is used to measure spread or dispersion around the mean of data set. So this gives us the information in terms of deviation characteristics. We are not giving any inferences in terms of saying that this is better or bad. Next is the variance. It's the distribution of data. Again, we found that the average of differences that exist from the mean. Say one person is taller, one person is shorter. We just expect in terms of how much of differences that exist between the mean from the average or from the mean. So it basically gives us an idea in terms of the spread of our data. All these are important because it helps in terms of the understandings. Next is quartiles. Quartiles is going to be basically, it's divided into 4 quarters in terms of 25%. Each one gives you in terms of the understanding in terms of the whether it's going in the upper first half or middle first half, it's in the middle or it's in the lower half. Though it's divided into 4, but we are it's more significant to find differentiate in terms of Q1, Q2, and Q3. Here, it's going to be very significant. That is, though it's a basic statistics in terms of the distributions, we claim which is more often ignored. We talk in terms of the bell curve, we discuss a lot in terms of the bell curves, but when we go in terms of in detail statistics or in terms of higher end interpretations, it starts from here. So basically, we have to have a proper understanding in terms of this bell curves and normal distributions. So it basically helps in terms of understanding in terms of distribution of the variable. Obviously, everyone anticipates and expects our research data to be in the best of symmetrical distribution, which is essential in terms.
Hello. Hello.
Yes.
Sir, it just got interrupted somewhere in the middle.
Is it audible now?
Yes, sir. If you could just go back that slide.
From normal distribution.
Yes, yes, sir.
So the basic statistics is important. Most of our significant statistical data starts from this normal distribution or the bell curves. Though it is not to many of us, your statistics starts from here, which is going to be the significant component of your inferential statistics starts from here. So the first and foremost important significant thing of your data has to be distributed. You have to check it for the even distribution of data. It is not that we have to have asymmetric distribution, but identification of the distribution is going to be significant here in terms of the analysis. So most important thing is to estimate.
Hello. Hello. Dr. Gopi? Hello? Hello? Hello, sir.
Disconnected. Lost its connection.
Should I give him a call?
Yeah, give him a call.
Yes.
Yeah, he's got disconnected.
Gopi sir, you are at mute. So unmute yourself.
Can you hear me now, sir?
Yes, sir.
So sorry for the interruption. It was a power failure, so it took some time to get back. So I think this slide is somewhere disturbing people.
True to its nature.
True to its nature.
People who go into that analysis know the difficulty.
Yeah, right now I've been given a sign to provide the increments on the basis of bell curve. Yeah, it's very unpredictable kind.
So bell curve has to be symmetric and it revolves around the mean. What does it signify? The mean, median, and mode of or equal distributions. And the normal distribution should have a high density in terms of the center and it should pale down in terms of the peripheries. Approximately 95% of your data should be within this normal distribution within the two standard deviations of the mean. Yes. So what is the significance of this bell curve? As said earlier, it is going to be, the entire analysis is going to be dependent on your bell curve data. So whether to choose a parametric or non-parametric test, it's going to be totally dependent on your bell curve distribution. If you have an equal distribution, you go for a parametric testing. If it's going to be unequal distribution, you go for a non-parametric test. This is a major place where we get into the issues. We predict we anticipate, or we say think in terms of data is going to be distributed, we go in terms of false statistics. We cannot blame the statisticians here, because the understanding of our subject is going to be slightly different when compared to their understandings. So it's essential that we give the required information or brief the statistician with all the required information to help in terms of analyzing things. Though the inputs of the data can help in terms of differentiating it, but there are going to be a lot of influences in terms of the study designs that can interpret it, change in terms of your analysis. So distribution, if it is normal, that helps in terms of understanding that we have an ideal or optimal sample size. So we are going to be also be, we are also satisfied in terms of the methodology that has been followed in terms of the inclusion and exclusion criteria in terms of recruiting the samples. And it also denotes the observations are made independent of one another and has same variances. The deviations from the bell curve is going to be either can be shifted to the left or right. We call it as skewness or kurtosis. If it's positive skew, we say that mean is slightly greater than the mode. So your analysis is going to be different. If it's going to be negative skew, the mode is going to be greater than the mean. Again, the analysis varies. Kurtosis talks about the peak of your bell curve. If it's going to be either it's highly peaked or shallow or moderately peaked. So again, it helps in terms of understanding of our data distribution, and accordingly, we have to change in terms of the analysis. So as said earlier, the test of normality is going to be the primary step in terms of your analysis. It's a basic requirement of any statistical analysis. Before you go in terms of any inferential analysis, we talk in terms of test of normalities. It can be done by two ways, graphically or numerically. Graphically, it helps in terms of understanding with this bell curves. Numerically, again, you have the common test that has been done is going to the Kolmogorov, Monov, or Shapiro-Wilk test. If at all you get back into the journals and articles or any JCs, we have this test commonly done before your analysis has been done. So this is the paramount important step which we have to follow before going in terms of your inferential statistics. The next major group of statistics is going to be your inferential statistics, which help in terms of establishing your inferences. That is, the results what you happen to obtain, we help in terms of finding the differences between the test group or in terms of the control group, or identify whether it's going to be different or the same. So that information is going to be obtained with your inferential statistics. Before going in detail about inferential statistics, people normally think that the statistical component comes only with that results data analysis, but it starts with your, as said earlier, it starts with your initial part of your designs like hypothesis testing. So hypothesis testing is more in terms of assumption of the study. I'm here discussing only the basic components here. I'm not going in detail about it because it doesn't fit in over here in terms of the slot as well as in terms of the part of this lecture. One is in terms of assumption of the study. That is going to be whether it's going to be right or wrong, may be or may not be true. So that is going to be your assumption of the study. So you talk in terms of testing of hypothesis in terms of accepting or rejecting the hypothesis. So it starts, your statistical analysis also or interpretation also starts from here. So you look into the data of the literature data. Accordingly, you decide in terms of whether you go in terms of a positive or null hypothesis or in terms of the alternate hypothesis. When you talk in terms of studying a population, it's always essential to study the entire populations. Say if you have Indian population which goes in billions, when you have in terms of that kind of population, it's difficult to analyze each and every person of the population. So you take a sample of it for the practical significance. So sample of the test has been chosen to evaluate the hypothesis going the critical component, which can be done unless and until you have an understanding of the statistical information that you have. According to that, you decide in terms of accepting or rejecting your hypothesis. So basically, you have two hypotheses, that is null and alternate hypothesis. In null hypothesis, you think the observations are going to be this as a result of purely by chance or not. alternate hypothesis will determine due to other reasons. So this is known to majority of the people here, but the idea of putting the thought over here is to make you understand the statistical component starts from here, rather than thinking in terms of at the result sections or in terms of interpreting of the data. So when you think in terms of hypothesis testing, you outline the hypothesis in terms of null or alternate, depending upon the literature evidences or in terms of statistical information which you collected from the pilot studies or in terms of the literatures that you have. Then you plan for the analysis, collect the sample data. Your sampling is also sample data, sampling methodology also going to be totally depend upon the evidences that you have in terms of the literature as well as in terms of the pilot study which you want to go on in terms of evaluating it. Then analyze the sample data, and finally is going to the interpretation of the results. The major concern over here is the thought process of majority of us is when we think in terms of statistics, we only talk in terms of discuss in terms of interpretation of the results, but we avoid in terms of discussing in terms of or when we start our hypothesis or when we start in terms of study or planning for the analysis or in terms of sample size selections. Well known in terms of decision errors. One is the type 2 error and type 1 error and type 2 error. Type 1 error is known as the incorrect rejection of two null hypothesis. Type 2 error is the deliberate error we make in terms of hypothesis. We deliberately try to avoid certain things in terms of the projection of the data or in terms of our methodologies. These two errors are very significant in terms of your decision making or in terms of the planning of studies. So the beginners who start in terms of your studies or in terms of your research, you need a proper understanding of this type 1 or type 2 error. In terms of simple words, type 1 error is the one which is not in our control. Type 2 errors which are under our control and which we are unable to avoid it. So deliberate errors are going to be type 2 errors. Type 1 error is going to be an uncontrollable error. So both these errors have to be minimized in our study designs. It should be very, very minimal. If it's going to be in vitro studies, somewhere in terms of 0.01 or 99% of confidence is supposed to be there, or the amount of error should be very, very less, ranging from 0.01 to 0.1%. Maximum is for maximum allowed is going to be 5% in terms of in vitro study. So majorly when the articles have been submitted to the journal and it's going to be similar kind of topics from different researchers, say for flexible strength of denture-based vessels. Same nanoparticles have been used by two groups of researchers and they're submitting the paper to us. It's not blindly we just reject the articles. We also look in terms of this level of significances, the impact of the study. The impact of the study and the error is going to be reduced. Then we think in terms of publishing an article which is going to be much superior than the other one. So there can be a complaint from the members saying that, no, I also did a similar study, but my study is not been published, whereas his study has been published. The reason behind that is this. Is in terms of the level of significance and or the amount of care that is being taken in terms of reducing the errors in the studies. Especially with your in vitro studies, the significance should be in terms of at the lowest level, that is the confidence should be at 99% or 0.01 error that is going to be very greatly appreciated by the society. So the confidence level is the amount of error that is reduced. So you say that I'm 90% of confident that my study is superior or the amount of errors is reduced in terms of my study. So something between 95 to 99 is going to be greater in terms of in vitro studies, or lesser than that is going to be more appreciated, especially with your material testing studies, because you have the environment in terms of highly controlled environment. The errors can be easily controlled and minimized. Why we are talking in terms of these errors? It gives you in terms of the power of the study, especially in terms of probability of not committing the type 2 error, which is a deliberate error, which can be avoided. It's not that we can do a study without error, but we say that we have a kind of error that is minimized. So that helps in terms of determining the power of study. And I have given you an explanation why it is significant, especially in terms of the publications and especially in terms of interpretations of the data. You want to have a high impact data saying that, no, my study is going to be superior. These errors have to be minimized. So that's the reason why we calculate in terms of type 1, type 2, or alpha, beta errors, or understanding in terms of this alpha, beta variables is essential. So this power analysis is useful in terms of identifying the impact of your study. Second is in terms of your sample sizes. Majority of studies do not have established sample sizes. I'll also go on detailed how to establish the sample sizes. So it helps in terms of determining your sample size, determining the impact of your study, and make comparisons between different statistical procedures in terms of determining whether a parametric test to be done or a non-parametric test to be done. Sample sizes are normally estimated from the literatures. If at all, it has got similarity in terms of materials and designs or methodology or operation procedures, protocol or standardization procedures. If you don't have a similarity in terms of these parameters or in terms of the objectives in which you're going to evaluate, then you cannot do a sample size estimation from your pilot literature. You have to go on towards the pilot study. Say, for example, I am testing two materials, adding a silver nanoparticle to a denture base. If it was a similar composition of percentage or similar nanoparticles has been added in the study, earlier literature studies, then I can use it for in terms of evaluating the sample sizes. If I'm going to test on a zinc and the literature is going to give in only in terms of the silver, then I have to redo a pilot study. I have to do a pilot study and establish my sample size. So this is the law of norms. It has various interpretations and people can differ with me. I'm not denying that. But by records, if there's going to be changes in terms of the composition of the materials or in terms of the design, we have to do a pilot study, establish the sample size, and go in terms of sample size estimations. So that is the method to go on. There can be deviations in thoughts and deviations in procedures, but all this will reflect in terms of your impact of your study. Maybe when we think in terms of in vitro studies, the impact is going to be very less. So people blindly go in terms of taking the pilot data, information from the literature and go on in terms of all the deviations. But this has a significant impact in terms of the clinical study. There's a major difference in terms of your acceptance or rejection of your studies in the international environment. So sample size helps in terms of the number of participants or specimens required for the study. It affects the study design significantly in terms of your power and impact of the study. Though we claim in terms of limitations of our resources, we need some smaller sample sizes, but smaller sample sizes as good have its own concerns. What we need is the optimal sample size that is required for that study. Larger sizes, maybe we might also contradict saying if I give you a smaller sample size, you have this issue. So instead of 10 patients, I'll take 20 patients blindly by saying giving a false data. But again, that leads to the ethical concerns. Second is the time consumption, especially in the pandemic, shifting from 10 to 20 patients, though the larger sample size is appreciated, but it's difficult to do it in the clinical environment in terms of the clinical studies, in terms of larger sample sizes. And additionally, the financial wastage, the time and energy that has been spent is going to be critical. These four values are very significant in terms of your calculation of sample sizes: the standard deviation, significance or power, and the effect size. You obtain this from the literature, if at all you have it in terms of a simulated literature, and you calculate these sample sizes from this. Conventionally, you have a lot of formulas, and the sample size calculations for each type of study is going to be different. If it's going to be an in vitro study, it is different. If it's going to be an observation study, it's different. If it's going to be a randomized clinical trial, it's going to be different. So you can calculate according to the formulas and according to textbook literature in which it is asked you to, which is just prescribed you to follow it, you follow it. But the more simpler method in terms of you, rather than using these formulas, you have this softwares. It's freely available software, especially GPAR, which is very easily available. It can be downloaded. If at all you have these values, you just incorporate these values into those text boxes, and it easily generates your sample sizes. If at all you find using this software is a bit complicated, you can use simple Excel sheets or Microsoft Excel to calculate your sample sizes. And you don't want to get much in detail about this. You don't want to get it troubled. You take it to the statistician and establish your sample sizes. But again, the statistician is going to look into this simple data, simple values to establish the sample sizes. So have an understanding of this so that it can help in terms of differentiating whether it is right or wrong, whether the statistician has understood whatever you have spoken to him in terms of establishing your sample sizes or in terms of the study data. The softwares known as GPower and all this Minitab, R package, and most commonly used as SPSS, all as is all you require is an understanding of the various softwares. And the simplest Excel can give you generate a software, but as it has its limitations, the person who used Excel in wider platforms will know the limitations, and and its applications. So it's not that totally impossible to generate a sample size calculations, to estimate the sample size, but can be done more simpler way with your understandings. So what is significant of the sampling? If your studies lack adequate sample size, it affects your impact. So it also affects your impact in terms of your appreciation and acceptance from various journals. So it's not necessarily that all has to have an increased sample sizes. Say for studies which is related to carcinomas, where we cannot get into bigger sizes because of the limitations, or even with the COVID at present situations which we have some limitations when we include the patients in the study groups. So when you include with some kind of compromise, that affects your impact of your studies, and of course it leads to a lot of debates, and appreciations cannot be at the greater level. So this is the major step in which,
yeah, we are running out of time.
Oh, sorry.
Yeah, could we conclude?
Next is the inferential. I'll go on. Thank you. Next is the inferential statistics, which is the basic thing which you're supposed to know about it. That's in terms of how it gets identified in terms of the statistical analysis. It is going to be one group or two groups or three groups, depending upon the interventional group, it varies. So basically, it's of two tests: parametric and non-parametric tests. It's t-test, z-test, ANOVA, which is commonly followed. Non-parametric is going to be chi-test, sign test, and man-Whitney test. How does it differentiate? Especially, you have to have an understanding between the groups that is going to be compared. If it's going to be one group and you're comparing to standard mean, it's going to be standard sample t-test. If it's going to be between two means of study group, it's going to be pan t-test, and varies accordingly in terms of the independent sample t-test. The major indication of t-test is depending upon the sample size. With sample size is going to be less than 30, go in terms of the t-test, and the data mesh is going to be critical about it. If the sample size is going to be more than 30, we go in terms of applications of using z-test. The commonest test is in terms of parametric test. If it's going to be more than three groups or two samples, more than two groups, we go in terms of ANOVA test. Again, we have one-way ANOVA, two-way ANOVA, and in terms of multiple ANOVAs, MANOVAs, and repeated ANOVA measures. When you do an ANOVA test, it helps in terms of differentiating the groups, but it doesn't help in terms of where the actual difference exists between each individual group. So you have to do a post-hoc test, and post-hoc tests are Tukey's, Bonferroni, Duncan's multiple range tests, and you have multiple of tests. Most commonly done is Tukey's and Bonferroni tests. Again, utilize the softwares to do this test. It's just incorporation of values to this software text boxes, and you can generate these values. Whatever we have in terms of a normal distribution, we have been discussing in terms of parametric tests. If the distributions are not going to be normal, then we have to think in terms of non-parametric tests. The exact equivalence for t-test or is going to be chi-test or man-Whitney test. All this is going to be the equivalence in terms of your non-parametric data. Remind you, when you go in for a non-parametric test, that shows that your has some inferiority in terms of your sample distributions or in terms of the data that has been collected. So it's going to be considered less important when compared to your parametric test. Last one is going to be a correlation or regression analysis, which we normally do. You relate it with one variable to the other in terms of the ratios or significance. In terms of establishing the relationship, normally it's in terms of what we do is establishing the relationship between the incisor to some geometrical proportions. So that's the correlation analysis we do, or we calculate a formula with help in terms of a regression analysis. The commonest test we use is in terms of Pearson correlations or Spearman rank correlation test. The simple scatter diagram helps in terms of understanding in terms of how exactly your study is being done in terms of positive correlations or negative correlations or no correlations, and helps us to differentiate easily in terms of when you submit your article in terms of accepting or rejecting it. When you have these graphs, this kind of displays, and we have something different in the values, we can easily get the point that there's some manipulations of the data that happens. There's a reason why most of the journals ask for these graphs, and helps in terms of correlating these graphs to the numerical values in terms of the significance or p-value. We can differentiate whether there's going to be some manipulations of the data that has been done. So it's easy for us to identify and differentiate the fairness of the study or the manipulation data. The carry-on thoughts is very simple. We have to know the need of statistics, the implications of the prosthodontics researchers, and the basic informations of statistical informations like types and methods of data collected, descriptive statistics, the various inferential statistical data, decision errors, power and impact of the studies, and the simplest in terms of the alpha and beta errors and correlation regression analysis. To summarize, it's not that earlier years where we just thinking in terms of statistician is going to be totally responsible for the data that is being available. It can go wrong if your understanding is going to be wrong. So you have a basic understanding of your statistical information is important so that you can put your thoughts aptly to the statistician and get the right data, which can improve the impact of the studies. I thank the opportunities that has been given to me. I also acknowledge the web resources from where I happen to adapt the images. Especially thank the organizing committee, the chairman, Dr. Narendra Padiyar, organizing secretary, Dr. Gaurapal Singh, Dr. Pragati for accepting this basic subject of basic presentations in the convention at the national platform. Thank all the organizing committee members in helping in terms of organizing this event in the best manner, especially in terms of getting it in terms of doing it virtually. It's quite difficult. And the most important is this, it's sending me the mementos much early before my presentation. It's not that easy. So full credits to the organizing committee. Thank for the mementos and the certificates that's given to me before my presentations. Being an organizing committee member for various conferences, I know the limitations of doing this. It's not that easy to just courier it to the people at the app time. Thank you for all your patient listening. Sorry for the disturbances, which was not in my control. And if at all you have any queries or that has to be discussed, you can email it to me or post your comments to the organizing committee. I'll be in a pleasure to discuss and give you the clarity in terms of either it's in terms of the presentations or in terms of any functional activity of the editorial board of the journal. Thank you. Sorry, Dr. George, your time.
Yeah. So at the onset, I take this opportunity to thank the organizing committee of the 23rd IPS PG convention for bestowing on me and my co-chairperson the honor of chairing the editorial board podium lecture. I also thank Dr. Gopichander for choosing this pertinent and unconventional topic, which is so essential for us to know to take out the meaning of what we are actually doing. So therefore, we all need to have a fundamental knowledge of statistics, which should be implemented and refreshed regularly. Thank you all.
Thank you, ma'am. Gopi sir, it was a nice, orientation towards statistics. I'm sure that student must have benefited. I have one, question for you, and I'm sure that is a very significant question. And nowadays, when the students are reading the articles from day-to-day basis, and the question is, what is the basic difference between a p-value and a confidence interval?
So I have to discuss more in detail about it. The limitation here.
Yes, sir. But a basic difference.
Yeah,
basic difference.
P-value is required now. We have been thinking in terms of all this probability, amount of probability that has been, or the amount of error that is going to be there, or amount of significance. I think it will be difficult for me to speak in a short frame. I need a more extensive time slot to speak on this.
Sir, but it was a really wonderful time we had, and it was a very good insight. Thank you so much, sir. I thank Dr. Cherian and Dr. Kamanshili for chairing the session. Can we have the certificate for the chairperson, technical team? Kamal ma'am, please accept the certificate.
Yes, please accept it. Thank you so much.
My pleasure, ma'am. Cherian sir, please accept the certificate,
Yeah.
sir.
Thank you. Thank you.
Thanks all of you. And we come to the next session, that is by Dr. George P. John, who will be talking on pedagogy, which is a very, very important topic. And that will be